Hello everyone and welcome to the learning curve. In this video I'll be continuing my illustration of a worked detailed solution to a typical final exam past paper for mathematics for social sciences, business and economics. In the previous installation I looked at solving a typical past paper question on exponential growth functions, in which we also applied the natural log to solve for the unknown t. In this video, I will be looking at a typical past paper problem involving solving systems of linear equations. This is a very typical question in final exam papers for mathematics for social sciences in level 1 at universities. So here we are given a system of linear equations which says 2x plus y is equal to 7, negative 3x plus z is equal to negative 8, and y plus 2z is equal to negative 3. This system of equation has three unknown variables, x, y, and z. In addition, there are three different equations. Hence, we will be having A as a 3 by 3 matrix. Write down the coefficient matrix A, and the constant vector B on the bar is what we are first asked to do. So let's write down the coefficient matrix A. So the coefficient matrix A is asking us to write down the values of the coefficients of the variables in each unknown, in each equation. So I'm going to have x, y, and z. The x column will represent the x coefficients for each of the equations. The y column will represent the y coefficients for each of the equations. And the z column will represent the z coefficients for each of the equations. Let's start with equation 1. This is equation 1. This is equation 2. And this is equation 3. Let's go. Equation 1, the coefficient of x is 2. That is the term paired with the x here, multiplied by x, so that's 2. The coefficient of y is an invisible 1. And there's no z in equation 1, hence we write 0 as the coefficient. Let's now go to equation 2. The coefficient of x in equation 2 is negative 3. The coefficient of z in equation 2 is an invisible positive 1 in front of the z. And there's no y in equation 2, so we'll use 0 as the coefficient. Now on to equation 3. In equation 3, there is no x value, so we'll use 0 as the coefficient for x. In that same equation, there is y with an invisible coefficient of 1. And z has an invisible coefficient of 2. So that takes care of the coefficient matrix A. Now let's write B on the bar. B on the bar is our column vector of constant equivalent values. And here they are. These are the values which are constants, must all be constants. On the other side of the equation, which are 7, negative 8, and negative 3. Those are the constants which represent the equivalent values for each of the equations. So that's B on the bar here. That takes care of number 1 in this matrix question. Now we are asked to find the determinant of the coefficient matrix A. So to find the determinant of the coefficient matrix A, I'm going to write the coefficient matrix A with the determinant symbol written around it. So 0 or 2, 1, 0. Just going to rewrite the matrix A here. So this is 2, 1, 0, negative 3, 0, 1, 0, 1, and 2. Then I'm going to put the determinant symbol around it. So here I write the 2 strokes around matrix A, indicating that we're going to find the determinant. Then I'm going to put alternate signs at the top of each column, starting with plus, then minus, then plus. That is necessary when you are going about finding the determinant of a 3 by 3 matrix. Then I'm going to write the first number to which we assigned a sign, that is 2. So we say this is going to be equal to 2 multiplied by the determinant of the 2 by 2 matrix that is left if we were to eliminate the row and the column that 2 is in. So if we eliminate this column and this row that 2 is in, I'd be left with these 4 elements here, which are 0, 1, 1, 2. So that is the 2 by 2 matrix that would be left when we eliminate the row and the column that 2 is in. Now let's go to the next column element to which we assign a sign, and that's negative 1. So we go negative 1 multiplied by the determinant of the 2 by 2 matrix that is left when we eliminate the column and the row that 1 is in. So when we eliminate the column and the row that 1 is in, we'll be left with negative 3, 1, 0, 2. There we are. Then we go to the final element to which we assigned a sign, which is 0. So that's going to be plus 0 multiplied by, then we write the determinant of what is left when we eliminate the column and the row that 0 is in. When we eliminate the column, or if we were to eliminate the column here and the row that 0 is in, then we'll be left with these 4 elements, which are negative 3, 0, and 0, 1. Now we will proceed to simplify this. So this will be equal to 2, open bracket, and we're going to find the determinant of this 2 by 2 matrix here. To find the determinant of a 2 by 2 matrix, we multiply the leading diagonal. So that will be 0 multiplied by 2, which is 0. Take away, always taking away. So it's the product of the leading diagonal minus the product of the off diagonal elements. So 0 multiplied by 2 gives us 0, and take away 1 multiplied by 1, which is 1. Then minus 1, open bracket. Then we'll do the same thing that we just did for the first 2 by 2 matrix here. So we multiply negative 3 by 2, multiply the leading diagonal, negative 3 by 2 gives us negative 6. Take away 0 multiplied by 1 gives us 0. Plus 0. Well, it does not matter what the determinant of this matrix's final 2 by 2 matrix here is, because we'll be multiplying by 0, and any quantity multiplied by 0 is 0, so this entire result would be 0. So now this simplifies to be 2 multiplied by 0 minus 1, which is negative 1. Take away 1 multiplied by negative 6, take away 0, which is negative 6. So the answer here would be 2 multiplied by negative 1, which is negative 2. And then negative 1 multiplied by negative 6 will give us a positive 6. A negative multiplied by a negative is positive. So we have negative 2 plus 6, which is the same as 6 minus 2. So the determinant of A is 4. Right? So we can write that here. Determinant A is equal to 4. That is the determinant of the coefficient matrix A. And that takes care of number 2 of this matrix question. Now, part 3 says we should use Cramer's rule to find the value of y only. Keep in mind that the system of equations has 3 unknowns. So in practice, we could be asked to find either x y or z, or we could be asked to find any one of them. In this scenario, we are asked to find y only. So, in order to find the value of y, using Cramer's rule, y would be equal to the determinant of ay divided by the determinant of a. If we were asked to find x, x would be equal to the determinant of ax divided by the determinant of a. And if we were asked to find z, z would be equal to the determinant of az divided by the determinant of a. So one of the important things that we need to define here before we can go further to find the determinant of ay is to actually define the matrix ay. So to find the matrix ay, we must first of all go back to the original matrix A, that is the coefficient matrix A, and recognize that y is the second column of numbers. Because y is the second column of numbers, according to Cramer's rule, we will take b on the bar, which is this column vector of equivalent constants, and we will use it to replace column y while the other columns in A remain the same. So ay would be 2, -3, 0. Then I'm going to use b on the bar to replace the y column. So this becomes 7, -8, -3. Z here remains the same. So that's 0, 1, and 2. The idea here is that if you were asked, for example, to find the value of x, then to find x, you would use b on the bar to replace the x column in defining ax, and the other columns would remain the same. Similarly, if you were asked to find z, you would use b on the bar to replace the z column, and the other columns would remain the same. Now that we have ay, we're going to find the determinant of ay. So ay is 2, -3, 0, 7, -8, -3, 0, 1, 2. So as we did for A, we're going to put plus, minus, plus above the first element in each column. 2 strokes around ay means we're finding the determinant of ay. So we start out by stating 2, the first element to which we assigned a sign, multiplied by the determinant of what is left when you eliminate the column here and the row that 2 is in, leaving us with -8, 1, -3, 2. Then we go to the 7, so we say now minus 7 multiplied by the determinant of what is left when we eliminate the column here and the row that 7 is in. That would leave us with -3, 0, 1, 2. So -3, 0, 1, 2. Then plus 0 multiplied by the determinant of what is left when we eliminate the column and the row that 0 is in. If we eliminate the column and the row that 0 is in, we'll be left with these 4 elements, which are -3, -8, 0, and -3. So when we simplify this, we get 2 multiplied by, so we open bracket, -8. We're going to multiply the leading diagonal elements here. -2 multiplied by -8 multiplied by +2 is going to be 16, -16, and -3 multiplied by 1 is going to give us -3. So that's what we get there. -8 multiplied by 2 gives us -16, and we are subtracting -3 multiplied by 1, because we're always subtracting the product of the diagonals. So this should be minus 3 right there. It's going to be eventually become a plus 3. So again, it's negative 8 multiplied by 2, which is negative 16. Take away negative 3 times 1, which is negative 3. So I'll have two negatives here. I'll use brackets to separate the signs for simplicity. Now minus 7 times, again we open bracket. When I open bracket here, I will get negative 3 multiplied by 2. You're multiplying the leading diagonal. Negative 3 multiplied by 2 there is going to give you negative 6. Take away 0 multiplied by 1. And 0 multiplied by 1 here is going to be 0. So we close that bracket now. Plus, it doesn't matter what this determinant here works out to. But when we multiply by 0, the answer is going to be 0. So this now becomes, when we simplify further, 2 multiplied by, this is going to become negative 16 plus 3. Because the negative multiplied by the negative right here is going to give us a positive 3. So that's negative 16 plus 3. Take away 7 multiplied by negative 6 minus 0 is negative 6. Plus 0. Okay? So that this becomes 2 multiplied by negative 16 plus 3. When we take negative 16 plus 3, it's like saying 3 minus 16. So therefore we would get negative 13. And then negative 7 multiplied by negative 6 is going to give us a positive 42. Of course, plus 0, so we don't need to include that. So 2 multiplied by 13 here, negative 13 here, gives us negative 26. And negative 26 plus 42 is the same as 42 minus 26. So the answer here is going to be positive 16. Therefore, referring back to Cramer's rule, which says that y is equal to, so y is equal to the determinant of ay divided by the determinant of a, then we realize that this will be equal to 16, which represents the determinant of ay, divided by 4, which represents the determinant of a. So this will be 16 divided by 4, so the value of y is 4. That's the answer for y. Thank you. I hope you found this to be very simple, straightforward, easy to follow, and that is the style of the Learning Curve Academy. Remember to like, share, and subscribe. See you again for the continuation of this series.